Hi, I'm Mary, and today I'm going to talk to you about how to deliver clean drinking water efficiently. And most importantly, we're going to learn how to use the scientific method to solve everyday problems. I work for PepsiCo, and PepsiCo manufactures multiple products that use water. It's important to our company that accessibility to clean, safe water is available so our consumers have a good experience when they consume our drinks. We extend that commitment and interest to the community with the belief that clean, safe water is critical for individuals to thrive. The way that you solve problems can be just as important as coming up with the solutions. Using the scientific method is a great way to logically look at a problem and using easy steps to come up with creative and unique solutions. To refresh your memory, let's take a look at the scientific method. Step 1. Ask the question that you want to solve. In this case, the question is, how can we ensure that Americans have access to clean drinking water? Step 2. Look at the current solutions. We can look in places like magazines, books, and the internet to see what's already been done. Step 3. What do you think are some solutions? This is what we call your hypothesis. Step 4 is the fun part. Let's test it out. Step 5. What did you learn from your experiments? Step 6. Look at your results, and if your hypothesis was correct, report them. Step 7. Look at your results. If your hypothesis was not correct, you need to make a new hypothesis and repeat steps 3 through 5 until you find a solution that works. The first step of the scientific method is to ask the question. In this case, the question is, how can we ensure that all Americans have access to clean drinking water? The second step of the scientific method is to do background research. Where does water come from? 70% of the earth is made of water. However, most of that water is salty and therefore not drinkable without further treatment. Where can we get this non-salty water? Well, we can look for it in places like ground sources, such as groundwater or aquifers, precipitation, which includes rain, hail, and snow, surface water, such as rivers, streams, or glaciers, biological sources, such as plants. We can actually get it through the sea if we go through a process of desalination or taking the salt out, and then all of this funnels into our water supply network. Based on our background research, there are a few constraints that prevent people from having access to clean water. Water needs to be transported from lakes or streams to our homes. This is expensive, and many current cities and towns have old pipes that need to be replaced or repaired. This can cost upward of $2 billion for a large urban area. Water needs to be treated to ensure that it is safe and clean to drink. And finally, water is an inherently local resource, and it's not always available everywhere due to seasonality and drought. Water can be more efficiently collected. Excess rainwater and wastewater can be channeled using water diversion or collection systems. These can be as simple as a ditch or a lake. Improving the efficiencies of these systems means that less water would be wasted. In the drought-prone Verde Valley, Arizona, there are collaboration with ditch companies to improve structures which enable more effective, efficient, and flexible water management systems. After the water is collected, it then has to be made safe to drink. I'm going to show you 2 animations that show how water can be cleaned up using a physical process to separate the different particles from the water. According to many different local water and environmental resources, water is currently treated first by physical sedimentation and then by filtration. It may then undergo osmosis to remove mineral contaminants such as phosphorus. At the end of these treatments, it should be safe to drink. Step 3 of the scientific method is about creating your hypothesis to answer the question. Using the information that we have learned, there are at least 2 hypotheses that we can test to answer the question, how can we ensure that clean drinking water is available to all Americans? The first one is upgrade diversion structures to improve the efficiency of water delivery systems. The second one is use the chemical and physical properties of water to clean it using filtration or chemical additives. Our first hypothesis is figuring out how to better collect water that is already available. Our second hypothesis is based on understanding that water is currently cleaned using physical separation of contaminants. I've given you some different hypotheses on delivering clean drinking water. Using the scientific method, write down any other hypotheses for how to get clean drinking water to people that may not have it available to them based on the background you have just learned or any other research you have conducted. Now let's test our hypothesis on improving diversion structures. We will test a rigid diversion structure and a more flexible diversion structure. Which one do you think will funnel more water into the bucket? The materials you will need are 2 100 milliliter beakers of water, 2 100 milliliters of water, 2 buckets that are larger than the beakers, a 4 by 6 inch piece of stiff cardboard or plastic, a 4 by 6 inch piece of flexible paper, a 100 milliliter graduated cylinder to measure the water, and pen and paper to record your findings. So what you're going to do for this experiment is you're going to measure out 100 milliliters of water into each beaker. Label the buckets rigid and flexible. Pour one of the beakers into the rigid bucket using the cardboard or plastic as a funnel. Pour the other beaker into the flexible bucket using the flexible paper. Then, take the graduated cylinder and measure the amount of water that is in each bucket. What happened in the experiment? Did the rigid structure overflow and spill water outside of the bucket? Did the flexible structure break? If you can bend and design the rigid structure, it works better to direct the water. However, if it becomes overloaded with water, it will overflow and water will be lost off the sides. The flexible structure allows water to soak into it, and therefore less water goes into the bucket. Paper will hold the water for a long time, leading to increased moisture in the air, which may change the weather patterns, leading to more rain and eventually more drinking water. In this experiment, we can think of the flexible system as being similar to a hill covered in plants such as grass or trees. How well would rainwater drain from such a hill into a lake or a stream? The rigid structure can be thought of as a concrete diversion system. How well would rainwater drain from such a structure into a lake or a stream? As a scientist, you will often see that there is not only one correct answer, and sometimes compromises have to be made. Would you rather have a flexible structure, like a hill covered in grass, to divert water, or would you rather have a rigid structure like concrete to divert water for drinking? Why? The second hypothesis is based on the understanding that water is currently cleaned using physical separation of contaminants. For this experiment, you'll need the following materials: 4 100 milliliter beakers, a half a cup of sugar, a half a cup of dirt, 2 spoons, a stopwatch, water to fill 2 of the beakers 3/4 full, 2 coffee filters, pen and paper to record your findings. To begin this experiment, you'll label the beakers 1A, 1B, 2A, and 2B. Fill beaker 1A and 2A 3/4 full of water each. For the first experiment, in beaker 1A, add the cup of sugar and stir for 30 seconds. Then you will pour the sugar water solution into the empty beaker labeled 1B through the coffee filter. Let it sit for 3 minutes and record what you see. For the second test, you'll take beaker 2A and dump the cup of dirt and stir for 30 seconds. You'll then pour the dirt water solution into the empty beaker labeled 2B through the coffee filter. You'll let it sit for 3 minutes and record what you see. For the first test with the sugar, did anything get stuck in the filter when you poured it into the beaker labeled 1B? What do you think is in beaker 1B? Is this water clean? Would you drink it? For test 2 with the dirt, did anything get stuck in the filter when you poured the dirt water into the beaker? What do you think is in beaker 2B? Is the water in beaker 2B clean? Would you drink it? Filtration works for larger particles. If we used a smaller filter size, we could filter out smaller and finer particles. However, with the sugar, it binds with the water not just physically, but also chemically. Therefore, it would be very difficult to remove sugar using a filter. We would have to use a very sophisticated filtration technique to filter out something like sugar because it's a small molecule that binds very tightly with the water. What are your conclusions on this experiment? Do you think filtration is a good method to clean water? By clearly thinking about the problem to solve, we can then logically come up with hypotheses to try to solve it. Testing your hypothesis doesn't have to be complicated. Design a simple method to test if you are right or wrong. What other hypotheses would you test to help deliver clean drinking water to all Americans? The scientific method is a roadmap to solve problems. We have more information available to us today than ever before, and this can make things more confusing and less clear. Knowing where to start when you are trying to solve a problem is key. We don't have to be intimidated by tough problems. By using the scientific method, we know how to start and where to go to find the answers. Even getting the wrong answer isn't bad. It helps us to think and can spark new ideas and solutions to current problems. Problems can be big or small, but breaking them down by using the scientific method can help us think through the information and test out potential solutions. What are problems that you see in your everyday life that can be solved using the scientific method? Some examples for you might be, how do I get a stain out of my clothes? Can I create cars that won't rust? The requirements to be a scientist or engineer at PepsiCo are in high school taking classes such as calculus and AP level chemistry or physics, in college majoring in things like food science, chemical engineering, packaging science, or polymer chemistry. Perhaps most importantly is having a passion, a curiosity, and a determination to learn. Think about the foods and drinks you eat and think about how they get to you. If this kind of project interests you, make sure to study science, technology, engineering, and math. The way you think about problems and how to solve them is just as important as the solutions. Using science, you can be part of developing ways in which water can be made drinkable for millions of people. You don't have to go at it alone. Many companies, including PepsiCo, have environmental sustainability programs. In summary, science and logic can help us unlock solutions to help people live better lives. Studying topics such as chemistry, food science, and polymer science will give you tools to creatively solve these types of problems. What's the one thing that you will do differently after watching this video? How can you conserve water in your community?